So hopefully you all have maybe got some of these. I've never used these before, so I'm just going to try it out. But the idea with these is like, if you need help, put up like a little red thing, and if you're good, put up a green one. There's a lot of people, and I don't have any like mentors to help out, so I can't guarantee that I'm going to be able to like spend too much time with anybody. So ideally, you can help your like if you finish early and someone else is you know, struggling next to you, we could try and help each other. But I will try and respond to the stickies. So I guess we'll get started. If you haven't already, please load up the binder link. Actually, show of hands, who has already loaded the binder link? Okay. Or actually, let's do it the other way around. Who has not loaded the binder link? And of those, how many? Who is having trouble loading it, and who just has? You know, who is having trouble with it? No one yet? Okay. So let's just assume that it's going to be okay, and by the time we actually need it, like the last stragglers will be fine. All right. Great. So I'm just going to start quickly with just a little overview of how this material is structured. So on the repo link, actually, and in the binder, there's a lot more material than we're going to cover in this tutorial. I could pretend that it's because I wanted to, you know, give you guys like extra material that you could use, but it's really because I don't know how long it takes to go through material. So I just wrote twice as much as can be covered in 3 hours. So there's plenty of extra bonus material. That may mean that we're going to be skipping some workbooks and some exercises are going to be just bonus exercises, but no worries. The material is also written to be done well, it works well in a self-paced manner. So if you go through later, if you missed something today, or if you were like, oh, I really wanted to learn this particular thing, you should be able to just go into the binder link, into the materials, and read what I've written and work through the exercises. Great. So the things that we are going to be covering are 3 things. The 2 big ones are going to be time zones and recurring events, because those are kind of complicated, and we'll have like a little light fare, which is working with the serializing and deserializing date times. Unfortunately, the way it works out is that the fun exercises come at the end, so I'm going to try and make sure that we get to those more fun exercises by the time, you know, with enough time for us to actually spend a good amount of time on them. But yeah, it's going to be a mix of lectures and exercises, and it starts out a little lecture heavy and ends up a little exercise heavy. Okay, but before we do any of that, I just wanted to get us all on the same page about date times, because when I've done this in the past, people have said that, actually a little background about me, which is that for the past 4 or 5 years, I'm afraid to calculate it because then I'll realize how old I am, and then, that death comes for us all. But for the past 4 or 5 years, I've been maintaining the library dateutil, which is a datetime library, does parsing, time zones, things like that. And we'll use it a lot in this material. But what that also means is that I've been kind of steeped in the world of datetimes, and I have no problem talking about calendrical arithmetic and all kinds of other like obscure datetime terminology. So if I kind of use unfamiliar terminology or a concept that you're not familiar with, feel free to like stop me and ask, because I actually don't remember which things that I learned while doing this and which things like I can assume to be common knowledge. So, feel free to stop me, because there's a lot of details involved. But I know there are a couple things that people have in the past had trouble with. I just want to establish the terminology. So the first thing, a very critical notion, is the difference between absolute and civil times. So, and I don't know that there's like a great standard terminology for this. So I call it absolute and civil times. Sometimes you can call it timestamps and wall times. But absolute times are a specific moment in time, right? So 15 minutes ago, 20 years ago, 1 minute after the beginning of the Unix epoch, those are all absolute times or timestamps. Civil times are, kind of a related concept, but what they are is the time it says on the wall, right? So civil times are not necessary. They don't necessarily reflect how much time is elapsed between two events or anything. They're really more what a human would expect the time to be, right? So if we're going to have a meeting at noon, and then all of a sudden the meaning of noon changes, right? Because like daylight saving time gets canceled with 2 days notice, right? We're not going to start having that meeting at 11 o'clock because we agreed that our meeting is in 75 hours, right? We're going to have our meeting at noon because we're humans and we get to work at 9 and we have our meetings at noon. Well, I guess maybe people go to lunch at noon. I'm sorry, I'm actually not a human. I'm more of like a robot, so I don't really understand lunch and human breakfast. With absolute times, they're usually the right choice for things in the past, so like logs, logging events. Sometimes they're used for things in the future like astronomical events or like chemical processes, things where you care about the elapsed time. Civil times are usually the right choice for things in the future, so like meetings, events, alarms, things where what really matters is that you get there when everyone agrees that it's noon, not when a certain amount of time has passed. With absolute times, you can store them as UTC or as a fixed offset, and with civil times, you generally want to store the local time, and sometimes you want to store the time zone that it's in. It depends. Okay, so with regards to, and this slide's a little big. With regards to, so now that we've established that, I'm going to talk about the Python's representation of datetimes. So Python has a standard library module called datetime. There's a class in there called datetime that represents a given datetime. Datetimes are immutable. So that means that if you try and if you try and change the values of a datetime, it will not work. This is useful so that you can use them as the keys for a dictionary or something like that. But what that means is if you want to get basically the same datetime but with something changed, you need to construct a new datetime. There's a convenience method for that called replace. So if you can pass it any number of the keyword arguments that would be passed to the constructor, and that's essentially the same thing as saying, give me the constructor for this datetime, but with some of the arguments replaced with this, right? And this will construct a brand new datetime. Then there's also a time delta time, right? So normally, if you think about, if you have two integers and you subtract one integer from another, you get an integer back. And if you have two floats and you subtract one float from another, or add two floats together, you get another float, right? Datetimes are different in that the class that represents a difference in datetimes is not a datetime, it's some elapsed time, it's time delta. This represents the difference in the wall times. It does not represent a difference in the elapsed time. So this is a difference in civil times, basically. So we can look at that by saying, all right, here is November 2nd at noon. If I add 24 hours to that, what I get is November 3rd at noon, even though the daylight saving time has ended, and now the UTC offset has changed. If I convert these both to UTC and then subtract one from the other, instead of getting 24 hours, I get 25 hours, right? So that's just something to know. There's a whole workbook in here that we're not going to cover that covers some of the more complex aspects of the of arithmetic semantics, but I just wanted to get just the baseline settled there. And then another big thing is aware versus naive datetimes. So a naive datetime, that's just what it's called, is when it has no time zone information. So the time zone is set to none or it's not specified. And that just represents a datetime, basically local time. You can consider it local system time. You could also consider it an abstract datetime, right, when you're just trying to do calendrical arithmetic. Basically, if you want to know, November 4th is always more than November 5th in the abstract, even if there's some weird time zone where that's not the case. And then an aware datetime is one where you've attached a datetime to a TZInfo to it, right? So this is a datetime that is aware that it is in Eastern time. So, and we'll have a whole section on time zones where I go into all the implications of that. Okay, great. So now that that is covered, do we have any questions? Okay, great. So we're all on the same page, and we will open up the first workbook. So the workbooks, you're gonna, if you've loaded a Jupyter Lab, I want to make sure this is in presentation mode. And all right, show of hands, who is having trouble seeing if I do this and like that? Is anyone having trouble seeing it? Okay, so a little bit bigger then. How about now? Anyone having trouble?
Can we turn off the front lights?
Sure. Does anyone in the back know how to do that? Or is this? All right, I'm just going to start pressing switches and let's just find out. No? I think I heard a fire alarm. Is that good? All right. Great. Okay, so, all right, now show of hands. Anyone having trouble seeing this? Yes, the binder is here. Okay, so if you have the binder loaded up, you should see here, it probably started you in materials, or it started you here. So you go into materials, and then 01-time_zones, and then load up the first workbook, which is called Python_time zones. Okay, great. So now we'll start on working with time zones. And the first thing I want to address here is that sometimes what you'll hear from people is like, oh, I don't like to deal with time zones. I just convert everything to UTC as soon as I get it, and then I work with that. And it makes everything super easy, right? This is a fairly common refrain. It's probably a refrain that may be, that may jive with your experience if you're like a system admin or something who actually works with absolute times all the time. But if you're, say, working in like business where you care about market closes and actual human times or some kind of recurring events, you'll find that that is not actually the greatest advice. Because, so for example, here, I've constructed an RRULE, and we'll spend more time on that later, but this is a recurring rule, and what it's going to do is it's going to generate date times during the weekday at 5 o'clock in New York, and that's basically market time for like market close time for like the New York Stock Exchange, right? So if I just look at this, you can see it says 5 o'clock on each of these days, and at some point it switches from being standard time to daylight saving time, right? And that was just a smooth experience. Now, if I wanted to just use UTC, what we would get is something where here I'm just going to convert all those date times we just generated into UTC. You can see at some point it starts, the market close time stops being at 10 o'clock and it starts being at like 9 o'clock, right? So if you wanted to just use UTC, you'd have to kind of know what the rules are for that and then figure out all the kind of aspects of that. And you know, there is actually something that does figure out all those rules, and that's the time zone objects. So unfortunately, as with far too many things with date times, there's not really simple rules. I'm not going to be able to just say like, here's a little slogan that you can go and you will be a master of date times. What's going to happen is I'm going to say, oh, it depends on your use case, and you know, do really good job testing, I guess. But hopefully I can give you some ideas of what to look for and how to understand this problem so that you can identify when you need to understand the shades of meaning between things. Okay, so in Python, the TZInfo class is an abstract base class, and all the concrete implementations, they implement at least these three methods: tzname, UTC offset, and DST. I'm not going to go into too much detail about exactly what they do, but basically the tzname tells you what the localized name is at the time that you request it. UTC offset is the offset, and then DST is actually the difference between standard time and the current offset. I would say if you ever find yourself trying to use this DST method, you're probably doing something wrong. This concept is not universal enough that I think you can rely on it for all time zones, and you can almost always get away with saying like, I don't care whether it's daylight saving time or not, I only care about what the name is and what the offset is. But you'll notice that these all take DT as a parameter, right? And DT meaning daytime. That's because what happens is if you, what these are is they represent a mapping from the local time to the absolute time, right? Or to the information that you, the time zone information that applies at that time. So here I'm going to show you, I have this little function, and this function, all it does is it invokes TZ name, UTC offset, and DSD. And you'll notice that I'm actually invoking these on the datetime. That's because the TZ name, the TZInfo methods are invoked by the datetime itself. So you only have to know that they're on the TZInfo if you're implementing a TZInfo, and you should probably not be implementing a TZInfo. Here I just have this thing. It's going to invoke them. It's going to print these out. And I'm going to create a single time zone object. This is like represents Eastern time. And I'm using dateutil's TZ module for that. And then I create a datetime that's in the standard time zone. And if I execute that, you can see that it says Eastern Standard Time, right? That's what applied on March 1st. -5, no daylight saving time. And then if I attach the exact same TZInfo to a datetime 1 month later, which is in daylight saving time, the offsets change, right? So this is something to note, is that generally you're attaching the exact same Python object to more than one datetime, and these map, and it's just a lazily implemented mapping to get the time zone offsets. All right, so I have this example. This was originally an exercise, but to be honest, I really don't want to be encouraging people to be implementing their own time zone classes, just because really the answer is like use a third-party time zone provider. But I can show you how it works, which is like def, tzname, self, dt, return, UTC, def, UTC offset, self, dt, return, time delta 0, and I don't know if I imported time delta, so I'm going to say from datetime import time delta, and then I'm going to do def, dst, self, dt. So this is one thing that that may be worth knowing. So reasonably speaking, you could return time delta 0 here as well, because it's always 0. But sometimes for these fixed offsets, and in the standard library they do this, you return none. And I think that's useful for certain third-party libraries if they want to detect whether something is a fixed offset or whether it has rules that just aren't in effect. I don't rely on that because I don't know that people consistently know about that. But there we go, that's our UTC thing, and these tests, I don't know, that's not a great visual spectacle, but behind the scenes I tested it against the standard library TZInfo. Okay, so let's get into something a little meatier, which is what you probably should be doing, which is working with third-party time zone providers. There's a little more complexity than we would hope because of historical reasons, but I'm just going to go through, I'm going to be talking about dateutil, which is the library I maintain, is also the best library. That's a completely objective opinion. And I'm also going to be talking about PyTZ, which is a legacy module that you should never use. But no, honestly, it served its purpose very well, and there's probably a lot of code out there that is working perfectly fine that's using PyTZ, and it is a little dangerous, so you may, I'm just going to try and go through a couple of the edge cases, so if you see something like this in production, you can fix it. Okay, so we'll start with our Eastern time zone again. You can see that if I attach it to this datetime, we have our standard thing. This is 2 o'clock Eastern Daylight Time, right? So the way I've used this is I've taken the Eastern object and I just attached it to the datetime by passing it to the TZInfo argument of the constructor. I'm not sure if you can pass this positionally. I never do it though. I always pass this as a keyword argument. Just, I don't know, it makes things a little clearer just because there's so many positional arguments for datetimes. So if I have this thing that I've constructed, if I want to reinterpret this as being in another time zone, right? So say we have some meeting that's in New York and then everyone from the meeting all goes to San Francisco all at the same time. And so the meeting is still at 2 o'clock, but we need to just shift the time zone. I'm just going to use dt.replace. Oh, and I accidentally pressed capital Z there. And you can see now here I have 2 o'clock UTC minus 4. The second one is UTC minus 7. If I want to reinterpret the original meeting, right? So for example, in the original meeting, everyone was in New York. Maybe instead of everyone moving to San Francisco, someone from the San Francisco office is now calling in. And so we want to know what time they should call in. And the answer is 11 o'clock. And we got that from using as time zone. So replace is saying, just reinterpret this. As time zone is saying, kind of do a unit conversion. Give me the same absolute time, but represented in a different local time. Okay, so with PyTZ, if you use as time zone, it works exactly as expected. And in general, PyTZ works well with these methods where you're taking something where you know the absolute time and converting it to another absolute time. But if you use a constructor or the replace method, which is equivalent, it actually fails horribly. So if you notice, now what I've done is I've tried to put this in Los Angeles time. But instead of getting what we were expecting up here, which is Pacific Daylight Time, we're getting this thing called LMT, and its offset is 7 hours and 53 minutes, or 7.88 hours. So that's obviously weird, right? The reason for this is that PyTZ does not use the standard Python time zone model, and I think it's a little beyond scope of this talk to explain exactly why that is, but I do have a blog post on that. Needless to say, it was a good idea at the time, and it is no longer really applicable. But what that means is that you can't just attach PyTZ zones either with replace or with the constructor. What you need to do is you need to call localize on the zone itself. Because what PyTZ does is, instead of acting as a mapping, it just is a factory for static mapping objects, right? It's just like when I made that UTC and I hard-coded what the TZ name is for all the date times, PyTZ does that for everything, and it decides which offset to attach when you call localize on the date time. So here, if I use localize, and actually I'm just going to change this to Los Angeles. So if I call Los Angeles, now we get what we were expecting if we're using localize instead of just using the constructor. The same thing will happen if you use arithmetic, because if you like add 180 days or 6 months or something, what that's basically doing is it calculates what the new date time is and then it attaches the same time zone object to the result. So what that means is that for dateutil, it works fine, because if we add 6 months, now we're in standard time. Now we're in standard time. Oh, now I have to change this back. So now we're in standard time 6 months later, but with PyTZ, because the same, it's hard-coded and doesn't actually pay attention to the datetime argument, then what that means is that you're going to see EDT, even though this never existed, right? It was never Eastern Daylight Time in February. To fix that, you have to call the normalize method, which will give you what you would expect by calling normalize on the result. So generally, my advice is, if you see something using PyTZ, see if you can use dateutil instead. And if not, you just have to be aware of making sure that you're very diligent about using localize and normalize. Okay, there are also alternate constructors, not the main constructor. So there's datetime.now and datetime.fromTimestamp. Both of these take a TZ argument. So if you call datetime.now or datetime.fromTimestamp, either of these are going to take basically an absolute time, right? Now is an absolute time. It's a specific moment in time. And they're going to represent that in your local system time. Timestamps are also an absolute time. They're Unix epoch times or whatever, so they're always denoted in, they're just numbers. It's number of seconds after the Unix epoch, so that's also an absolute time. Both of these will give you naive date times that are represented in the system local time. So the result of this from timestamp will depend on what system you're on. So here it's 2020-11. I think on the binder, because this is running on my laptop, which is set to Eastern time, on the binder this will probably give you a different result, like 10 o'clock or something like that, right? I generally prefer, if possible, to attach a time zone to it. Unless you really just want the local system time, that's fine. But you can attach a system time to it, and it will work just fine with PyTZ and with dateutil. So here, if I take from time zone and I want it in Eastern time, in both cases I'll get. I'm not sure why those are different. It doesn't really matter. What I said is true, so I think. I may have done something funky here, but in any case, you'll see that this is the local time that corresponds to that absolute time in that time zone. So generally speaking, if you want the local time like now in UTC, you use datetime.now and then pass TZ equals TZ UTC or whatever UTC object you're using. There are these sort of semi-deprecated methods in the standard library, UTC now and UTC from timestamp, which will give you a naive local time that is basically the same as passing UTC to the TZ argument and then removing the time zone. But honestly, I don't recommend using these because there are other parts of Python that treats naive time zones as local times, and it will cause confusion. So generally, if you want the local time in UTC, use the TZ argument. Okay, so this brings us to our first argument, and I'm sorry that I talked for so long. Did I say argument? Exercise, I meant. And here we're going to work on getting the current time in multiple time zones. So let's practice using time zones by implementing this function. And this function is going to take as an argument a list of strings, and you can pass to get time zones from those strings. If you have from dateutil import tz, you can do say Tokyo equals tz.getTZ. This is the best way to get a time zone from a string. Asia Tokyo, and that will give you the time zone that you want. So so here, just implement this function, and what we'd like to do is we'd like to see the current time printed in all the time zones that that are in the list. And you'll note that these are all the exact same time. They're not like milliseconds or microseconds after each other. That's because I only used datetime.now one time. If you call datetime.now like 5 times, you'll get slightly different times because it has microsecond precision. So yeah, so go ahead, try and implement that, and try and use exactly one thing. If you're having trouble getting started, put up one of the red Post-its. I'll give you a couple minutes. Let's take like 10 or 15 minutes for this. Oh, and when you're done, put up the green one. If I start seeing, a lot of green, like, in 5 minutes, then we can just move on. Got. Anyone else having trouble? Yeah, okay. If you're still working, feel free to continue working, or I'm just gonna run through it real quick, do a live code, and then, you know, if you wanna try and, if you're having problems still and you wanna try and see how I did it, hopefully this will help. Okay, so I'm gonna show you how I would do this. There's like basically a bunch of slightly different ways that will all have the same effect. So the first thing I'm gonna do is, I don't really want to worry about the edge cases with the lists and stuff, so I'm just going to say from datetime import timezone. I could also use dateutils UTC, but I'm just going to show you this because then you'll know that it exists. And then I'm going to say dt equals datetime.now timezone.utc. That'll get me the datetime in UTC. This could be any aware datetime. I just picked UTC because it's a nice reference time. And then we'll say for TZS in TZ list, DT, let's say DTL equals DT dot as timezone, TZ dot get TZ, TZS, print DTL, and then there we go. Oh, and if I wanted it to have this thing, I would have to have some more complicated formatter, right? So I'd do something like TZS colon. I'm not going to bother with the other part where it gets them all aligned to the right at the same time. But that is in the answers. Oh, there's also answers for all of these as well. Like it's in a Python file that's sibling to the exercises. Forgot to mention that. Okay, great. So does anyone have any questions so far on just working with time zones, PyTZ versus dateutil, anything like that?
What type of object is
Timezone.utc is a timezone object, which is a subclass of TZInfo. Timezone and timezone.utc is a singleton. It's a single instance of a timezone, which is fixed offsets, and that was added in Python 3.2. So if you use Python 2.7, you won't be able to use this timezone.utc, but all of that stuff is in dateutil. So if you use tz.utc, which is another UTC singleton, that will work just as well. Okay, any other questions? Yeah, is this visible now? Is this all right? Even bigger? Well, you should, oh yeah, here we go. So yeah, also I don't know if I did exactly the same thing, but I probably did a more correct version of it in this sibling directory. So if you go to TZ answers, you can see what, how I implemented it there. If you're having trouble reading the screen. Okay, all right, so I'm going to move on to the next case, which is, this is our first interesting edge case, which is ambiguous and imaginary times. So, obviously, and you're always talking at the water cooler like, oh, did you see that ambiguous time? Like, they're so ambiguous. And then they'll be like, yeah, at least it wasn't imaginary, right? Am I right? Okay, so, but no, obviously this is not water cooler gossip. This is a specific datetime terminology. So an ambiguous time is when you have, in a given zone, two different absolute times that map to the same local wall time, right? So this will happen anytime you set your clocks back. So here, I guess it was like Halloween 2004 was, I guess, a Sunday. So the way it worked was that at 2 o'clock, so first it was 1:30, and then it was 1:49, and then it was 1 o'clock, right? And the only difference was Eastern, one is Eastern Daylight Time, the other is Eastern Standard Time. For a long time, Python could just literally not handle this because there was no as we talked about before, the TZInfo is a mapping from wall times, the naive portion of the datetime, to the information that applies at that time, right? But these datetimes are actually distinguished only by the offset information. So it needs to be an input to the function, but it's also the output that you're trying to calculate. So there was just no way to express this. You couldn't round trip anything like this. This is in fact why PyTZ has its weird interface, because it can handle this. But in Python 3.6, PEP 495 was accepted. And what that does is it introduces a fold attribute to datetime. So what it does is it just adds fold. If you set fold equal to 1, or if you set fold equal, if folded defaults to 0, if it's 0, then it just represents the first occurrence of the datetime. If it's 1, it represents the second occurrence of the datetime. And 0 and 1 are the only valid options. So now we have this solved, and dateutil can handle this. But of course, that's only if you're using Python 3.6 or greater. But there is a backport for this. So in dateutil, here, I guess what I'm. Oh, so I'll talk about the backport in a second. Sorry. Right. So if you're dealing with these ambiguous times, as timezone will just always work both for dateutil and PyTZ, right? Because again, this is another one of those situations where having an existing absolute time makes these much easier, right? So PyTZ is always able to calculate the right offset given an existing absolute time. And dateutil is always able to calculate what fold should be given an absolute time, because it knows how to do the mapping. PyTZ obviously also knows how to do this. If you have a sort of naive time, if you're doing replace or wall time or something, and you need backwards compatibility for Python 2, dateutil also provides an enfold method. So what this does is that on Python 3, it just is like replace fold equals 1 with a little bit of logic to not do any replacement if the fold is already 1, right? But on Python 2, what this does is that if the fold needs to be set to 1, then it will give you a backport, like a backported object, which is called datetime with fold, and that just adds fold back into datetime. Generally speaking, you don't like print the reppers of these things, but essentially, in any case that I've ever seen, you can just use tz.enfold for all backwards compatible cases, and then when you go to Python 3 only, you just replace it with just regular fold equals 1. Okay, so that's one side of the story, right, which is sort of working with it if you already know that something is ambiguous and you want to choose one or the other. If you want to detect ambiguous times, dateutil has a function for that. Generally speaking, if you just want to always default to std, you can just pass fold, right? So if you just pass fold equals 1, then the fold is actually ignored in any case where it's not ambiguous. So you don't really have to know this information too much. The one time that you would want to call this function is if you have a situation where you as the developer don't actually know what you want the user to do or something, right? So it's actually an ambiguous case and you're saying this is out of scope, or I need to query for what to do in this case. I need a policy or something. So you would do something like raise an exception if there's an ambiguous case, or maybe you just log it, right? You say, this was an ambiguous case, I defaulted to the daylight saving time. And yeah, if you just set fold equals 1, it'll just ignore it if you're not ambiguous. Okay, so the next step is thinking about imaginary times. So the conjugate of ambiguous times, where there's 2 wall times that have the same nominal value, is imaginary times when a nominal wall clock never even exists in a zone. So, I mean, for some examples, you could say like that example where PyTZ was attaching EDT to something in February. That is a kind of ambiguous or a kind of imaginary time. But the more common one is when there's a gap because you're switching your clocks forward. So in this case here, it was, in March of 2004, it was 1:59, and then it was 3 o'clock, right? So nothing about Python will stop you from constructing an imaginary time, right? Because Python is very lazy about its time zone handling. You only get that information if you need it. So if I go through and I just add 1 hour or just do a replace, you can see it'll happily construct imaginary times. That's why dateutil has this tz.datetime-exists function, so you can check if it exists and then do something with it, whatever you want to do with it, right? If the datetime doesn't exist in that time zone, you can make your choice. There's also this thing called resolve imaginary that I added, and that essentially just skips you forward. So if I think a lot of times this is what you want. So you're adding 1 hour at a time, and then there's a gap, right? And if you fall into the gap, a lot of times you're just like shift me over, right? Instead of going from from 1:30 to 2:30, just go 1:30 to 3:30. But if that gap is some other weird amount of time, you can't always just add an hour. So resolve imaginary handles that. So here's a case where in Kiribati in like 1994, they wanted to switch which side of the international dateline they were on. So there was just a missing day. And I guess the missing day was all of December 31st. So it was like December 30th, and then the next day was January 1st. And interesting story about this. This was in my test suite in dateutil, and then someone was like digging through the like South Pacific newspapers or whatever, and they're like, in the time zone database, this is saying that January 1st was skipped, but in the newspapers it says that December 31st was the one that was skipped. And then they were like, oh, that was our mistake. And then they updated it. And now I have this weird check, which is like, oh, is this imaginary? Well, maybe we'll check if the other one's imaginary. So even like the past is sometimes, the mappings in the past are sometimes not super stable. Okay. So again, I recommend using dateutil, but if you have to use PyTZ, I'm going to just give you the information that you need to understand it. So with PyTZ, they use the localize function, and if you localize something, it defaults to if you localize an ambiguous datetime, it will default to the standard side, which was what the Python standard library originally said to do. If you want to get the first occurrence, or the daylight saving time side, you pass to localize is_dst equals true. And I think that's ignored if it's not ambiguous. So here, if I want to localize these, you can pass is_dst equals false or nothing, and it'll give you the standard side. Pass is_dst equals true, and it will give you the daylight saving time side. But if you want to detect ambiguous times, then you pass is_dst equals none. And what it'll do is it will throw this ambiguous time error. So if you want to recreate the dateutil version of this datetime_ambiguous, then you would just do this try catch. For imaginary times, PyTZ will happily create an imaginary datetime, and then it'll just assign it like an offset based on what you say for is_dst, which again I think defaults to false. And if you pass it none, then it will raise this pytz.non-existent time error. So basically, you can get, other than the fact that PyTZ uses this weird localize method, they have a method to handle everything you can do with dateutil with PyTZ. Though again, I don't necessarily recommend it. So here's another exercise, which is hopefully we have, I think we have time for this. What I'd like you to do is say that you have some system. You can see where my bias is here, right? Let's imagine that you have some system, and we're going to call it a legacy system that's using PyTZ. And someone's like, well, we have all this behavior based around PyTZ's localized stuff. And you say, well, you know what? I am a big proponent of dateutil. So what I'd like to do is I would like to write this compatibility function for you. And it's going to be called localize, and it basically does exactly what PyTZ's localize does. It takes a datetime, a TZInfo, and then DST, and it recreates PyTZ's functionality about raising errors. This is something you may actually legitimately want anyway in terms of, again, if you want the isDST equals none behavior. Okay, so let's take 15 minutes for that. Again, put up the red if you have a problem and the green if you're done, and I'll come around. behavior of PyTZ that I neglected to mention, but I actually am testing for, is that localize can only be used on naive time zones, and normalize can only be used on aware time zones. So you may have implemented this, and then it's like you're not raising value error. Just note that that's because if we're actually trying to build a PyTZ style exactly localizer, then it wants you to raise value error if you get a time zone, if you get a datetime with a TZInfo attached. So if the TZInfo is not none. Was that clear? Is anyone unclear on that? Okay, so, all right. Unless you're naive. Maybe, yeah, sorry, yeah. Localize, TZInfo has to be none. Normalize, TZInfo cannot be none. See what I mean? It's like localize, normalize is the same as localize except for aware datetimes. So let's just focus on localize. Localize has to be called on naive datetimes. If you call it on an aware datetime, then it will raise an error. feel free, oh, sorry, I keep messing with this microphone. After this, please do send me feedback because I realized that some of these error messages are probably ambiguous. I could probably do better. So I'm very much looking forward to adjusting this tutorial for future people. So just saying that. By the way, I think we're at 15 minutes. Do we have one more question? Let's take one more minute. How many people have something that works even a little bit? Just like a couple. Okay. I'll give you like 1 or 2 more minutes. Okay, so it's been 15 minutes. How many people finished? Show of hands. Like 1. Okay. All right. Well, I'm just going to go through it. And I realize now. All right. How many people were like 70% done? All right. And how many people were like 50% done? And how many people just didn't know how to start? Oh, okay. Yeah, that's what the red sticky is for, guys. I'm surprised, given that there's 50 people, I'm surprised at how little I've had to like walk around. So feel free to, I hope I don't regret saying that, but feel free to like make extra use of that red sticky because I want everyone to get something out of this for sure. All right, so I'm just going to show you how I would do it. It's that, but I'll say, okay, so the first thing I'm going to handle is I'll check the case that the edge case that we mentioned about the value error. So if dt.TZInfo is not none, raise value error localized can only be used with time zone, naive time zones. And I really hope no one here is on the Unicode Standards Committee because I did not use the diaresis in naive. I'm so sorry about that. I just don't know how to type it. So then what I'm going to do is I'll handle the isDST. So there's 2 ways you can do this. One, you can just set the fold one way or the other, and it will work. So I'll show you how to do that. I'll show you that way, right? Which is just to say dt.fold equals int. I mean, you don't really have to do the int part, but not is DST. I'm not sure if the semantics of this are exactly right because I suppose there's possibilities where you're like in Ireland, this might cause some problem. This might be slightly different, but those are very hard to detect. But they're not in the test suite either way. But just to note that the fold has an inverted sense of isDST because the standard, usually you're going from daylight saving time to standard time when you're setting your clocks back. So that means standard time is the second occurrence, which means fold should be 1. And then we'll say if, oh wait, actually first I have to say if is DST is none, we'll say, now this is the case where we have to throw an error. So we'll say try, or actually we'll say if tz.datetime.ambiguous dt.replace, oh actually I can just do this. Raise, oh and also I can't do that. I'm sorry. Raise ambiguous time error. Okay, and then I'll say elif tz dot datetime dot, sorry, datetime underscore ambiguous. Not, I don't know why I thought this should be datetime exists and not datetime imaginary. dt tzI raise non-existent time error dt does not exist in TZI. And then finally, we'll say fold equals, actually, all right, I guess I'll say fold equals 0, else fold here, and then finally I do dt dot replace TZInfo equals TZI, fold equals fold, and we're going to return that. And let's check the tests. And it passes all the tests. Another way to do this would be, instead of setting, here I'm just setting the fold like indiscriminately, which means that if I do like localize datetime dot now tz dot get tz America New York, then it's going to set fold equals 1, even though this is not an ambiguous time. So if I want to fix that, I can say, I mean, fixed, it doesn't really matter, but if I say if tz dot datetime ambiguous dt tzI, that'll still pass all the tests, and when I localize it, it won't have the fold. So there we go, and that works. Great. So I'm going to, at this point, I'm going to skip the last two workbooks. The first one is about handling local times. You should be able to read through it, and it's fine. One thing I will note is if you go through this, locally and you don't have time zone information, some of these demos won't work. I noticed that the demos didn't quite work when I tried it on the binder originally, and I had to install the TZ data. Windows, it will definitely not work, because it turns out that this is something you may want to know, is that if you change the system time zone during the course of a Python run, like say if you wanted to demonstrate what it looks like to do some Python things that take place in different locales, on Windows it will just not do it. Like, you have to restart Python to get the new local time zone information. So, and there's like pretty much no way around that. You can get different local time zone information if you use dateutil.tz.tzwin local, but I didn't. I was trying to demonstrate something else. So yeah, so go ahead and work through these two. Probably do the local time one on the binder if you're on Windows. And frankly, I haven't tested any of this on Windows, so it might all be broken. Yes. Well, I mean, there is dateutil.tz.tzwin local, which actually queries the registry whenever you construct it, and the registry will get updated. It's that you have to call this tzset function in time in order to get dateutil.tz local to work. So, like, generally speaking, try not to change your local time zone while a Python run is happening. It doesn't happen too often, but yeah, there's a lot of edge cases around that. Okay, all right. Let's see. All right, so I think the break is probably at 3 o'clock, so we're going to go through the serializing and deserializing. So you can go, if you're in the time zone 1, just go up 1 level to materials, and then go down 1 level to 02-serializing_deserializing, and we'll open the first workbook. We may not get to the other workbooks, but at least the first workbook is a good start. Yes. Yeah, so not is DST. fold has the opposite sense of isDST because, well, I mean, they just map to different concepts. So isDST is like, are you on the daylight saving time side? But there are other situations that could cause folds. So for example, like Portugal, at one point canceled daylight saving time, and they wanted to do it with a minimum of like problems. So what they did was they just waited until daylight saving time, or you know what, they shifted their base offset. So they shifted their base offset. So instead of being UTC plus 2 during standard time, they switched to being like UTC plus 1 or UTC plus 3. I forget which one. And they were, I think they were also canceling daylight saving time, or maybe not. I don't know. But they. Oh no, it's going to be true, false, or none. Yeah. So like if you were going to write types for this, it would be, yeah, sorry, I misunderstood that. It would be like bool and then none or something, or optional, or actually, and I think this would have to be, yeah. So false means choose standard time if it's an option. True means choose daylight saving time if it's an option, and none means throw an error if you're uncertain. Like, so that's exactly what PyTZ does. You can see it up here, right, where here true does one thing, false is the default, it does another thing, and then none throws errors. Yeah. Okay, so any other questions on this? Okay, great. All right, let's jump to workbook 1 strings. All right, so no, go for it. Yes. isDST kind of has the inverse sense of false. I mean, yeah. Yeah, they are. But I cast it to int. I mean, you don't have to. Oh yeah, if you pass true or false, it'll just get cast to int like automatically. I mean, you could. I'm not even sure. You may be able to pass the string 0 or 1. I don't know. Yeah, the reason why it's 0 or 1, I think, is because the underlying representation, if you add just an unsigned character instead of like a Boolean, it wouldn't make datetimes take up any more space because of the alignment, the padding for alignment in the C structure. So like, I think they were like very specific that the only valid values are not like Python objects. They're like 0 or 1. Yeah. Okay, cool. So let's jump into serializing and deserializing datetimes. And then I think well, we can stop for a break at 3 o'clock. I think that's also when there's going to be like tea and stuff outside. Okay, so serializing and deserializing datetimes. So I have a couple workbooks on here. The second two are probably going to have to be just do self-paced. But this is a fairly common operation that you're going to do, right? Because you need to represent your datetimes in some format that's either going to be independent of programming language, or you're going to have to transmit it to something that you really shouldn't be transmitting, like Python binary objects, or maybe you're just sort of serializing it by writing it to a log file that a human being is going to read. Generally speaking, if a human is going to read it, you're going to want to use some sort of a string representation that's unambiguous and compact. If no human is going to read it, we would jump to workbook 2 and probably just represent it as like a number, because that can be easier. And then workbook 3, I don't have time to go into it, but I deal with JSON, because JSON, as with many other programming languages and such, including Python, frankly, don't treat datetimes as a kind of first-class type. They're not primitive types, but they're so common that it causes a lot of problems when people just have to create all their own different standard ways to represent them. And so the JSON standard does not have any way to represent datetimes. So you just have to like represent it as a string and then have like a schema that says this is a datetime, convert it from a datetime, or you have to like have some sort of self-describing like superset of JSON, right? Where it's like, oh, you know, if I have like a little curly bracket and it says object and then datetime and then a string or whatever. So the last one at least lets you add hooks for JSON. But you have to work out all the stuff that goes around that because it's not standardized. YAML, on the other hand, does standardize datetimes, but has other problems. Okay, so, oh, and one other thing I'd like to note before I go on to this deserializing and serializing as strings is the difference between what I'm calling deserializing and parsing. So deserializing does involve a parse, right? Because it involves taking a string and then turning it into like the core values and turning that into a datetime object. But that's really a subset of all parsing tasks, right? Because a lot of times when you think of parsing, you're thinking of things like maybe like parsing user input, right? Where they're going to be typing a datetime as a string, and it might be in one of 16 million different formats, or you know, someone from the business team gives you an Excel spreadsheet, and they've got a column with you know, half the datetimes are like year slash month slash day, and then the other half are like year dash month dash day, or some other weird thing like that. And you as a programmer are not able to be like, well, I really only support this one format, right? Because you don't control what your users do. You know, and if you make that mistake, you're going to be making the same mistake as, you know, whatever programmer is making it so that like someone named John Null is unable to get on airplanes, right? Like, oh, John Null, that's just some fake thing. It's probably test data. Let's just throw it away. You know, like you don't get to choose how people are going to give you their datetime formats necessarily, and you also don't get to choose, you know, like what people's names are going to be. But when you're deserializing, and that's why I was very specific about that's what we're going to cover here. That's because it's either you're reading it from a serialization format, which is standardized, right? So you're saying like part of the standard is that we use ISO 8601, which itself is actually quite ambiguous. And then, or it's maybe something you generated yourself, right? So it's like you're writing some sort of microservice kind of operation, and you just have some interchange format, and maybe you want to be able to read the data in packet captures or something, so you want it to be strings, but you don't have to worry about arbitrary datetimes because you're controlling both sides. So we're going to be talking about the latter case, the case where you control both formats, but you know, this is a refrain I go to a lot with datetime, and with a lot of things, honestly. It depends on your use case, and try and be careful about not mistaking one use case for another. Okay, so when you're going for a string format, you want something that's going to be unambiguous, something that's going to be easy to parse, preferably fast, and ideally fairly compact, right? You don't want it to take up a huge amount of space. Probably there's two ways to do this. One, you can use strftime, and in that case it will be, as long as you know what the format is, the format string you choose, it will be unambiguous, but it may not be unambiguous to people who don't know what that string is. If you use ISO format, which does a very specific subset of ISO 8601, though it's also able to generate a superset of ISO 8601. So yeah, things are complicated. There is an easy way to invert ISO format, and then there's, and mostly people looking at ISO 8601 datetimes, they will just be able to look at it and say, that's what this is, right? It's unambiguous that it goes year, month, day, because you know, the only Middle Indian people are like the Americans, and we usually represent it month, day, year. Yeah, sorry. I mean, yeah, I'm Canadian. I didn't just say TZ a million times. Canadians say Z. Sorry. Anyway, yeah. So we have this datetime.iso format. It has two arguments: sep, which specifies what the separator between the date portion and the time portion is going to be. It defaults to t, which is what the standard says you should do, and then timespec, which determines the amount of truncation. And you can tell that I was putting off writing the rest of this talk because I spent like an inordinate amount of time making this ASCII diagram. So we're just going to bask in that for like a couple seconds. Look at this. Yeah. All right. So this is all the formats that it can generate. Basically, the default is that it will generate this. It'll generate this much if there are if there's no microseconds. So if the microseconds are 0, the auto will generate this, and if the microseconds are anything other than 0, it'll generate that. If there's a time zone attached, it will generate as much of this portion as is necessary. So usually it's HHMM. If you're in some weird time zone, like one of the PyTZ LMT zones, you'll sometimes get seconds. I don't know of any times when you'll get microseconds, but there is support for that. So like we can take a look. You can see if I have microseconds, it looks like that. If I don't have microseconds, it'll auto truncate. If I want to specifically make sure that I have microseconds, I can just specify any one of these things to say use all of that. There's no way to specify this. You can't always get microseconds for the time zone portion of it. You can also specify more truncation. So you can say hours, and then even though I have stuff in minutes and seconds, it'll just get truncated. If you want something that's more like what you print, like what the statement for printing a datetime, you can change the separator to a space, or you can change it to whatever you want. That can actually be any Unicode character. Like I think even like weird non-supported like things not in UTF-8, like surrogate characters and stuff. And then for aware datetimes, you can see it'll just have this offset. And then, right, it supports all of these things. So before Python 3.7, there was no way to invert this, like literally no way to cover all the use cases. Even strp time wasn't able to handle it because strp time only supported the inverse of strf time, and strf time does not have this colon, and there's no way to specify it. Python 3.7 brings two additions. One is strp time. If you use the %z directive, it will now parse it correctly even if there's a colon. And then the other thing it brings is from ISO format. And I know all this weird stuff about the separators and stuff because I actually added from ISO format to Python. So what this does is, and I also am like super specific about the guarantees. Like most people will be like, oh, it just parses ISO 8601 times. So I'm like, no, you're not allowed to say that. Because what it actually does is it inverts the output of ISO format. It's a subtle difference, but it's a difference in the contract, right? Which means that there's not going to be a Z at the end. Like you can't take any ISO 8601 datetime and parse it with this. You can only take things that are the output of ISO format. If you want something that parses ISO 8601 datetimes and only ISO 8601 datetimes, dateutil has dateutil.parser.iso parse. And that will work for a wider array of datetimes. Yeah, so that'll work, and that will also work before Python 3.7. But this is much faster. It's an interesting thing to note is that from ISO format, if you pass it a string literal, it's actually faster to do that to get a datetime than to create a datetime literal. Like it's like maybe twice as fast. And the reason for that is like, this is just on CPython, and I wouldn't like rely on that because we might optimize other things. But it turns out the reason for that is like CPython spends like a surprising amount of time parsing the arguments. So if you give it from ISO format and it just takes one string, it's just like, oh, turn that into a C string, and then the parse takes like 10 nanoseconds, and then it spends most of the time constructing the datetime. So anyway, that's some weird optimization thing that you probably shouldn't, it's like dangerous knowledge. You probably shouldn't even know it. So great, so that brings us to our exercise, which is write a function to parse a log message. We have this bonus exercise down here that I'm going to tell you about now because we're not going to get to it, which is this is some logger format, and we're going to use an ISO 8601 datetime because these are absolute times, and we're going to be time zone aware. We're not going to make it UTC because when you're reading logs, you prefer to see things that are at least kind of in the ballpark of what your local time is, right? And if you want to configure your parser to have something that from ISO format can understand, you have to reconfigure it. So that's the bonus exercise, is to actually change the logger to work this way. And it turns out that if you want to ignore the microseconds part, and you also don't want to be able to like, and you don't want this colon, it's like trivial to do this, and it's like a nightmare to do if you don't want that, because you have to like subclass formatter and then like do all this weird stuff. So the answer, like, feel free to try your hand at that if you're going to be like the logging guru, but otherwise it's probably not worth your time. So we're going to say that someone like slaved over this and figured out how to generate this output just to make it easier for you to do the log messages. And we'd like to write a parser that will take this, it'll break it apart, and then it'll have some structured JSON object that has the fields datetime, which is the datetime, and then level, which we'll just keep it as a string. If you want to map it to an enum, like if you're super fancy, you can do that, but don't waste too much time on it. And then the name, and then the message. In the test suite, I don't have anything that where like the message contains a colon or anything, so that's fine. But if you want to handle that edge case, you could just use split with like, the split takes a second argument, and if you pass it 4, it'll be fine. Okay, great. So let's take like 10 minutes for this, and I think that brings us to the break. So you can work into the break or whatever. I'll be around and make sure I can help. So green when you're done, red if you need help. Oh, so it's 3 o'clock now. I think 3 o'clock was like the scheduled break time. I'm not entirely sure, but there may be like refreshments out there. If you guys, should I just go over the answer real quick? I'm sure a lot of you are probably still working on it, but I'll just show it to you and then you can pay attention or not, and I'll be around during the break so you can ask me questions if you just want to keep working on it. But the way I would do this is I would say, let's say dtstr level name message equals line dot split, splitting on a colon with 2 spaces on it. Oh, stay on page for sure. And then I'm going to put 4 because I want at most 4 of these. And then I will say, or I want, like, yeah, at most 4, I think. And then I just have to convert the DT string into a datetime. So datetime from ISO format, dtstr, and then we can return datetime dt level name message. And there we go. And we'll check the tests. There we go. So that's how I did it. So we'll do a break.
You're going to lose some of the message if the message contains space quote space.
Oh, no, actually, I won't. See, here, look. Blah, blah. Wait, sorry, this should be a 3. The second argument to split truncates how many, it's like if you find this 3 times, once you find this 3 times, like stop. Yeah, just like keep going for the end. So yeah, I always forget if it's like the number of values you want returned or the number of separators off by 1. Okay, yeah, so we'll start up again at 3:20. Head out there. If someone like starts yelling at you, like, get back in the room, like, just let me know, I guess. Yeah, I'll be here for questions on this or anything. It's 3:23, and someone asked me a question about leap seconds, so my ire is up. So I think we'll jump right into something soothing and talk about recurring events. So just a reminder, we're skipping the other two workbooks in the serializing and deserializing. Those will just be self-paced. And we're going to jump to section 03-recurring_events, workbook 01, introduction. The first workbook just has one like example thing, and if as you're going along, you can feel free to like run some of these. Like I have some little bonus exercises you can play around with, but I want to make sure that we definitely get to the second workbook because I think that's a more fun exercise. It was fun for me, so I don't know how well that generalizes. Okay, so we're going to talk about recurring events. You would hope that it would be easy to express a recurring event because it's like this just happens every day, or it happens every every 5 hours or something. But I think we all know where this is going. That's obviously not going to be terribly simple because we have a lot of overloaded terms in DateTimes, and we have a lot of colloquial meanings like what is the length of 1 month, or or even 1 year, right? There's not a fixed amount of time that elapses in 1 month. So we need some kind of better way to clearly and in a standard way express things that recur. So I think the best standard that we can get for this comes from RFC 5545, which is the iCalendar spec. And this is actually like some kind of string format that is used for interchange between different like calendar systems. I think maybe ICS is based on this. And it's like this long spec. This is the second version. There's another version that this displaced. And then there are addendums to this. And it's like 170 pages of like iCalendar stuff. And we are going to represent all our recurring times using the data type that's defined in like subsection 3.3.10. So it has like all these different types. And of this 170 page spec, the next two workbooks will be devoted to a type defined in these 8 pages. So I try and be as compliant with the spec as possible with my DateTime implementation of this. But some of the things are a little dicey, and there was some non-compliant stuff that was already there before I took over DateTime. Another note is in DateTime, the way this worked out was that RFC 2445 was standardized in the IETF, and then DateTime was written, and then it was updated with RFC 5545 at like 5 or 6 years later, and DateTime never got totally upgraded. So I have some support for 5545. If you're interested in making open source contributions, I would love to see more support. The code in here is kind of tricky, but I would love to see someone go in there and take a crack at it. Okay, the type that we're talking about is called an RRULE, which is a recurrence rule. It describes a recurrence. There are 3 fundamental elements. They're like required elements. There's DT start, which is the start date of the recurrence. And if you're like a physicist, this is kind of like the phase of it. This has some consequences. Basically, anything that doesn't recur, like, it picks up its original elements from the DT start. So that's something to note. And then there's freq, which is like the fundamental frequency, and that can be yearly, monthly, weekly, daily, hourly, minutely, or secondly. And then there's interval, which is basically the multiplier for freq, right? So if you have, so let's work with these actually. So first I'm going to import all these like weird constants and stuff, and then I'm going to describe this rule, which is an hourly rule. So hourly is an RRULE. Its frequency is hourly. Interval is 1, and it starts on this day in 2016 at 9 a.m. So when I print this, you can see that it does what you would expect, right? It generates a date time at 9, and then one at 10, and then one at 11. And these things are also like at least semi-immutable, but instead of mutating them, you really should, like even if it's possible, you should use replace to generate a new one. now I'm just going to take that original rule, and I'm just going to change DT start, right? So if I change DT start to 10 o'clock, we get the same hourly rule, 3 occurrences, 10, 11, 12, right? Straightforward. And then interval, if I change that from 1 to 2, the multiplier on hourly changes from 1 to 2, right? So what that means is that I'm going to get 9, 11, and 13 instead of 9, 10, 11. I'm not sure, like this is a very redundant spec, so generally I would say go with the simplest possible rule that you can, and I think try to minimize the number of dates that are filtered out. Well, I'll get to that. Okay, so normally, if you'll notice I have this count argument here. Normally, if you just take an RRULE and you don't limit it in any way, you don't put count or until, that's just kind of a more abstract thing, and it says like generate recurrences indefinitely. Indefinitely just means until the year 10,000 when datetime can't represent, like the datetime class can't represent it anymore, and then it throws an error. So generally, like these things are just like lazily generate your datetimes. So it's pretty easy to generate them, but then as long as you don't call list on it, it'll be fine. But if you want to like clearly limit it, there are two options. There's count and until. Count says like give me this number of them. You know, I want. In this case, I was like show me 3 of them. There's also until. So you can imagine like you know, I need to like I have bar mitzvah practice at Hebrew Skill or whatever every Saturday at 12. But then when you turn 13, you're going to get bar mitzvahed. So then that is no longer necessary, right? So you would generate a rule that happens every Saturday, and then it stops on your 13th birthday. So that would be an example of like an RRULE. And then you can also, as I mentioned before, if you have one of these things that is indefinite, you can also just get a subset of them, right? So there's no natural number that you want. You just really want like, okay, I want the next occurrence after next Friday, or like the last occurrence of this before some date. So there are 3 options. There's after, before, and between. After and before generate just one datetime, and then between generates a list. So here I have this monthly thing. It says every 4 months, starting in 1995. And I can just say, all right, so given this rule, I want to know the next thing that is an even number of months, an even number of 4-month intervals after this time, after 2015, like February 2015. And you can see that it's March 10th. And then the last one before the 1997 is in November of 1996. And then all of the recurrences in 2001 is between 2001 January 1st and January 1st, 2002, and we get these 3 occurrences. Okay, so I'm not going to pause for this, but feel free to, like, if you can listen and do it at the same time, to just play around and, you know, generate something that does every day at 1:30, or like every other week for 6 weeks, and then play around with like what does after do after the last recurrence. I think it probably returns none. Oh, and the other thing is, I forgot to mention this, but count and until are mutually exclusive, so you can't use both. You can implement something that will use both in a sense, which is to say, like, you specify one and then you just generate dates and then throw an error or stop iterating over it once you reach the until. But the spec says that you can specify one or the other and not both. So I think right now it's just a warning, but it will eventually be an error in dateutil. Okay, so that's fairly simple. You know, that's something you could basically do with time delta, other than with the yearlies and stuff. But then it gets a little more complicated when you use these by rules. So by rules are rules that modify the base recurrence. So for example, and they have like by month day, by year day, by week number, by weekday, and then these like exotic ones like by set pause. This by Easter is the only thing that's not in the spec that's in dateutil. I think like this since the beginning of DateUtil, it's had support for calculating Easter, and I don't know, like maybe the original developer was like, well, we got these Easter days around, like we might as well. But I can imagine it being useful if you schedule something that has to happen on Good Friday or something, right? The way these are interpreted is a little counterintuitive, and I wish I had like an intuitive explanation of why it works this way, and I'm sure there is one, like based on the Nyquist theorem or something, but I just haven't come up with it yet. But when the by XXX rule, or like when the by rule specifies a component whose like duration is greater than or equal to the frequency, then it's a constraint, and it's going to reduce the frequency of the occurrence. So for example here, I have this RRULE, and RRULE, it's daily, so it's going to generate every single day. It's going to generate it, and then I'm going to use these larger components by month of 11, and by weekday, Tuesday, that's equal to, it's like roughly equal to a time, right? And so what that means is it's going to generate a bunch of daily, it's going to generate one instance every single day, and then if that day is not in November, or if that day is not Tuesday, then it will ignore that and move on to the next one, right? So I've set a count of 5, and I have this restricted, but I'm starting in January of 2015. And if you look, I get, just with my count of 5, I get 4 Tuesdays in November in 2015 and 1 in 2016. So you can see how like the count interacts with this, where you're generating a specific number of days that have these rules, right? So the by rules for larger components, they're filters, and it'll cut down, it'll just filter everything out except for this. Oh, and these accept scalars, and they also accept like pretty much any container type. So tuples, lists, things like that. If the rule is less than the frequency, then it increases the number of occurrences, right? So here's another rule. This is a monthly rule, and there's more than one day in a month, right? So the bi-month day is a lower frequency, or is a higher frequency. Like the duration is shorter than a month, right? So these bi-month days are going to increase the number of occurrences. So what I have here is I say every month on the 1st, 15th, and 30th of the month, I want recurrences. So you can see, even though the DT start is not a recurrence, it's going to give me the first, it starts with the first one, that is the 30th, and then it gives me the 1st, 15th, and you'll note that at the end of the month, it didn't like fall back to January or to February 28th, and it didn't like jump forward to March 1st. Well, I guess you could imagine that it did, but I'll tell you it did not. Because if I change this to the 2nd of the month, you can see that it goes to March 2nd, right? The rule is that if a date time does not exist in the calendar system, then you skip it. And there's no way to configure this in DateUtil. There is a way to configure it in the like more recent specs, but it's like it's a little complicated to implement, and I haven't done it yet. So I've used by weekday a couple times. This is kind of one of the more interesting ones, and it has kind of a little complicated use case, like the way it interacts with the other components. Weekday is one that you'll use a lot, and it's just, says that a recurrence will happen on a specific day of the week. And normally I just use the constants directly, like Tuesday, Friday, something like that. But occasionally you want to use, you want something like the first Friday of the month or the last Friday of the month. So you can pass an argument, and this is an index, and it's an index into the number of occurrences of like the Friday or of that day of the week within the period of the frequency. So if the frequency is anything less than monthly, it will just give you every Friday no matter what number you put there. If you use a monthly rule, then it will give you just, in this case, the first Friday of the month and the last Friday of the month, right? So this is the first Friday, that's the last Friday. If the frequency is, this one is first Friday, last Friday, first Friday, last Friday. If the frequency is yearly, then it'll give you the first Friday of the year and the last Friday of the year. So this interaction I found out about when I was writing these slides, so it's not super well known. Yes?
Is the offset based off of the standard definition? Because it seems odd that the first of anything would be the, I mean, you rarely pick up an offset in zero.
This is not a Python thing. It's like it comes from the iCalendar. So yeah, I think it's a one-based index in both directions. So the first and the last is -1. The first is 1. Right. So yeah, and for the small ones, it's like this is like every Friday. But yeah, so generally speaking, with these, unless you actually need a very specific frequency for the reason that you're like using these weekday things and it actually matters what the frequency is, try and keep the frequency, basically think about what it would look like what the rule would look like without filtering anything out, and try and pick the thing that generates the least number of date times that get filtered out, because under the hood, that will actually make things much slower. So if I had like a secondly rule that generates every single second from like with DT start of like 1970, and then I'm like filtering by day and by hour and by minute and by second, so that it's actually just like a specific time of day once a year, it will generate like thousands and thousands of date times, and then most of them will get filtered out. So, I mean, maybe it doesn't generate actual date times, but it does a whole lot of math that it doesn't need to do. So try and keep the filtering to a minimum for performance reasons, but don't jump to that until you're starting to see performance problems. Probably it's like a good baseline thing to do, but it may be that in 6 months I find some way to like normalize these things, and there will actually be no performance difference. So I'm just going to show an example of how you can use this to generate something that may be hard to express otherwise. So Martin Luther King Day is a U.S. holiday, and it's always the third Monday in January. So and its first observance was in 1986. So let's say DT start equals date time 1986 1 and we'll do our rule will be frequency equals monthly, because we need the third Monday of the month, and then by weekday equals Monday 1. I guess I don't need this. And then it needs to be in January, so we'll say by month equals 1. And then I think that is it, right? The third month. Oh, you're right. It's the third Monday, not the first one. Yeah, but this is a monthly rule, so otherwise it would generate January, February. Yeah, I mean, you could use this if you had like a meetup every third Monday of the month or something, right? And then we need DT start. DT start. I think by default, DT start will be just like the current date time, so always specify your DT start. Interval defaults to 1, frequency is required. Okay, so we'll test this, and I guess it just passed. Sorry, I need more flair with these, where it like prints some amazing thing. So yeah, so you can see how this would be useful. There's also something related to this for things like this, which is called relative delta, and that's a workbook we're not going to get to, but it's materials/04, and there's like another 20 minutes worth of material there. Okay, so we have an hour left. I'd like to take this. We're going to do this last workbook. This is like a very interactive one. So I think we're going to do 10 minutes per exercise for this. And then depending on when we're done, we can either jump back to one of the workbooks we skipped, or we can just do like 20 minutes of Q&A or something like that. Or we won't even get it done in the next hour. So let's see how it goes. All right, so far, honestly, the things that we've done with our rules are, the things that we've done with our rules so far can get you very far, right? They can do things like, a certain, most holidays, they can get you most kinds of meetings and things like that. But there's kind of also more complicated things like, for example, every Sunday of the year, except for Mother's Day, right? And there's no way to express that because it's actually like kind of an overlap of two different rules, right? And that's what the RRULE set is for. RRULE set is kind of like a set for like of recurrences. And the way it works is that you can combine basically anything that generates datetimes to make just a set of recurrences. And the interface looks like this. It is each one of these RRULE sets is mutable, so you'll like construct one and then you'll just sort of add things to it and subtract from it. It has RRULE, which adds a recurrence rule to the set, XRule, which cancels out recurrences, RDate, which is like adding one-off dates, and then XDate, which cancels one-off dates. So let's play around with this. Right, so we'll start with RRULE. When you have two RRULEs and they can be combined to make one set of recurrences. So for example here, I have two rules. One is the end of the month, and the other is like the last Friday of the month. So you can imagine maybe you have some kind of event that happens at the end of the month and also the last Friday, like you have an alarm and you want it to happen on the last Friday because the developers are in it's like the day before they're gonna go out for the weekend. And then maybe you also want an alarm for that anyone who's on call will actually see, right, during the day that it's actually possibly going to be a problem, which is like some monthly transition or something. I don't know why I spend so much time on this flavor text. So here's what I have, right? I have expressed these two things, and I kind of snuck in this end of the month rule because this is actually a kind of hard thing to express without that skipping back thing. So this uses BySetPos, which I did not spend any time talking about, and you can like read the spec, and if you do that, you'll probably understand it even better than me. But it's basically saying like generate like this monthly thing generates 4 datetimes in its set, or up to 4, depending on which ones exist. And then BySetPos is saying filter that down to be the last one. So that's how this one works. Yeah. I think no. I suppose it's, I don't know. Let's see. Oh, then maybe it does work. I don't know. Maybe, yeah, honestly, I didn't even realize that this one worked, and then I like was reading something and I was like, oh my goodness, this works. And then I like found myself talking about that a year earlier, like, oh my goodness, this works. So I like learn things about this and then immediately forget it. So yes, I suppose it's very possible that if by month day worked when you checked it out, then either there's an edge case that I wasn't thinking about, or I was just being stupid when I made these slides. I think both of them are well within the realm of possibility. Okay, so no matter how we've constructed it, I can now combine these two, and I have my RRULE set. I add one RRULE, I add the other RRULE, and then we're going to print them out. And so you'll notice I have 2 entries in March, and I have 2 entries in April. But then in May, I only have 1 entry, right? And the reason for that is that the last day of the month in May is a Friday. And this and the sort of set part of this is not really, that's not just like it actually has properties like a set has, in the sense that if more than one recurrence rule is generating a given date time, it will only show that recurrence once. So in this case, both rules generated the last day of May, and so it said, okay, we'll just generate the last day of May and ignore all the other rules that are also generating the last day of May. So that's something. So now we're going to start the exercise. And this exercise here, it runs through the whole workbook, and it's essentially, so they build off of one another. So if you end up like messing things up, you may have to end up using like kernel, restart, and run all cells a couple times, just in case, like, because you know how Jupyter has like, it has state that can like persist in a way that you don't realize it. So the exercise is that we're going to build a bus schedule, and bus schedules are can be complicated. So hopefully we can see some of the complexity. So the way it works, what we're going to do is we're going to start with the base schedule, and the base schedule says that on weekdays, Monday through Friday, the bus comes once an hour, 37 minutes after the hour, starting at 6:37 and running until 10:37, right? So that's one recurrence per hour, and that's a total of, I don't know, however many, 23 minus 6 is. And then on weekends, it has a different schedule. It's like reduced schedule or something. From 8:07 to 7:07 at night, it comes every hour 7 minutes after the hour. So you can, if you don't want to bother, like the two RRULEs for generating the schedules, there's not anything terribly interesting about like making the same thing twice. So you can make the same, you can make that schedule. Feel free to like either make the schedule for the weekday or the weekend, or you can just use the like weekday schedule, and then you write the RRULE for the weekend schedule, and then you combine them. And when you're done with that, you just run this, you uncomment this, and run RR tests, test basic bus schedule. All right, so let's take 10 minutes, and that goes until 4 o'clock. And then, remember, red if you need help, or raise your hand or something. Oh, one thing I forgot to mention, if you want to see this, I guess I didn't put it here, but there's this thing, helper, is it up here? Oh, so I have a helper function that makes it easier to see this. It's called display underscore bus underscore schedule. And you can see your progress. Like this is just the weekdays. So this is maybe like a convenient way to look at your progress instead of parsing some complicated list of date times. it's 4, and I think whether if you've done or if you're done or not, let's just. All right. So how many people are still working? Okay, it's a good fraction. I think it's probably best to move on, but you can still work on it. Work and listen. But obviously since these build on each other, you'll need the output of the first one for the second one. So if you don't end up getting it before it's time for the next one, you can just do weekend schedule. Well, you can do weekend schedule equals RR_answers dot get weekend schedule, and now you have the weekend and weekday schedules, and then you do bus schedule dot RRULE weekday schedule bus schedule dot RRULE weekend schedule, and that adds them both. And now what's happening here? Oh, I put weekday schedule. I meant to put bus schedule. Now I have these. Okay, but I'm going to go through quickly how I would do the weekday schedule one. So we'll say weekday schedule equals RRULE. And you can use a daily rule or a monthly rule. It doesn't, or an hourly rule or whatever. It doesn't really matter. I'm going to use a daily rule because there will be less things filtered out. Freq equals daily, and then we know that we want to start equals, let's say, we already have our DT start at the top, and the rule is that we need to do it every hour on the hour between 6 and 10. So I'm going to say by hour equals range, and again you can use pretty much any iterator here, 6 and 23, and then by minute equals 37, because I want it to be on the 37. And then I need to filter it by weekdays. So I'll say by weekday equals weekdays, and I've helpfully defined that above. And then for weekend schedule, it's basically the same thing, except instead of weekdays, it's weekends. And instead of 6 to 11, it is 8 to 20. And instead of 37, it's 7. And now if I run these three right here, then I get, oh, this is wrong. Oh, it's because I named this weekday schedule. My mistake. There we go. So you can see we have our schedule. It should look like that. Okay, and if I run the tests, hey, it works. All right, so let's move on next to discussing XRule. So XRule is just like RRULE, except instead of adding date times or adding recurrences, it just takes them away. So what happens is, under the hood, it's going to just generate, one recurrence from each of the different RRULEs and one recurrence from each of the different XRULEs, and then it's going to, pop them off in order. And if an XRule matches a recurrence, matches any of the RRULEs or RDates, it's just going to obliterate that and then keep moving down the line. And if it doesn't match anything, it just keeps moving down the line. So this is again very similar to the diff behavior of a set, right? If you have a set that has 1, 5, and 7 in it, and then you subtract 7, you get 1, 5. And if you subtract 9, you get 1, 5. So here, I'm going to use XRule to implement that rule that I said we couldn't do with just a pure RRULE, right? Which is every Sunday except Mother's Day. And Mother's Day is one of these, I'm going to just make this monthly. Is one of these second Sunday of the month kind of things. And it says, so if I do this, that's weird. I guess yearly works, right? Because that's actually when Mother's Day is. So maybe I misled you about this Sunday thing. Maybe if you have a bi-month, it's equivalent to being monthly. This is so confusing. So yeah, but in any case, let's just do it the other way. So I have my every Sunday rule. I have my Mother's Day rule. I will create a rule set. I'll make that the base of the, I'll make the every Sunday rule the base with RRULE, and then I'll exclude every Mother's Day. So if I combine them together, you can see Mother's Day is May 12th, 2019, and then if you combine the two, you get, you know, Sunday, 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 and then a gap, and then Sunday, Sunday. So that's it. One useful trick that I found for limiting some rules, right, is that you may have some kind of complicated rule, and then you want to like cut out a certain, like you want to cut out a certain subset of it. You can use rrule.replace to do this by generating. You basically take an rrule, you take the exact same, you create the exact same rrule, but modify it in some slight way, right? And then you add that as an XRule. So it's going to be generating based on very similar rules. So for example, here I have a rule that generates every single Friday. So it's a weekly rule Friday, and it generates it at 9 and 5 every Friday, 9 and 5. And then say I want to exclude from that rule anything that's on Friday the 13th. You can't just kind of have like a filter lambda or whatever that's like anything that matches this filtered out. So what you have to do is you have to generate the same date times, and you can do that by just adding the by month day, which to 13, right? So we want this rule, but only when it falls on Friday the 13th. And if I add one and then subtract the other, then I'm going to get, you know, 9 and 5 every Friday except for Friday the 13th. Okay, so now we're going to go with the next exercise, which is to reduce the evening bus service. So you know, after rush hour or whatever, we'll say that the buses, instead of coming every hour, they come every other hour. So we're going to take our original bus schedule, and we want to drop. We're going to drop all the recurrences that occur after every other recurrence that occurs after 6 p.m. So the 7 o'clock and 9 o'clock buses, they just are not in the schedule anymore. So go ahead and we'll take our original bus schedule object and modify that with like an XRule, or I mean, I'm just being suggestive, but yeah, an XRule. And then uncomment this for the tests, and then we'll look at the answer at 418. So someone just mentioned that I actually made a mistake here. This is not supposed to be, like this will just pass this test because it's this is test basic bus schedule, so you're gonna have to change that to evening. So test evening base schedule, bus schedule, and that will actually throw errors until you fix it. Of course, it's a totally uninformative error. It's like, oh, this is wrong. So again, sorry about that. So it's 4:18, so I'm going to take a crack at this. All right, so here we have, so now what we have so far, I'm going to display the schedule, display bus, schedule, bus, schedule. Right, so what we have so far is we have our regular rule, and what we need to eliminate is this occurrence and this occurrence. So that's a rule that can be deleted, so we're going to use XRule for that. So now what I need is I need the subset of, I need a rule that generates only these occurrences and these occurrences, right? So what I'll get is I'll have evening reduced equals RRULE freak equals, actually I can use that replace trick, right? So I can say weekday schedule dot replace. So I want to generate the exact same rule as we used for the weekday schedule, but now instead of by hour being like 6, 7, 8, 9, 10, I only want the ones that are 7 and 9 in the evening. So I can say by hour equals 19 and 21. You can probably be, you can also maybe do like range 19, 23, 2, something like that, but it's only 2 elements, so it's actually less typing to just specify all the hours. So now I have that, and I'm just gonna see if it's exactly what I want, right? Evening reduced. You can see, yep, that's exactly what I wanted. I just want the ones on the weekends, or the weeknights. Okay, so then I will take my bus schedule and I will add this as an XRule. Evening reduced, and when we check it again, here we go. It's looking good, and this is no longer failing. Okay, great. So now we've covered adding rules, we've covered subtracting rules, and then the last thing is sort of one-offs, right? There's no specific rule that generates these things. It's really just this subset of it is this extra thing is happening, or this particular date it just gets canceled, right? So you can imagine there's a meeting that's every Wednesday at 2 o'clock, and the person who organized the meeting is on vacation on June 12th, right? That's not something that's recurring. It's not every June 12th. It's just June 12th. So what we do is if we have our rule for a meeting, we create an RRULE set, and we add the meeting as the basis, and then we say, let's just take the recurrence that happens on June 12th, and we could get that from dot after or dot before or whatever, or we can just manually put it in there. And then we'll add that as an X date, right? So it's just like cancel it out. And so then what happens is we have, it'll just skip the one on Wednesday. But then you can imagine the meeting organizers, they're just out for that one day because they had like a dance recital or something. And so they just rescheduled for the next day. So instead of it being June 12th at 2 o'clock, it's June 13th at 10 a.m. So we can just do our, again, one-off exception. We'll use our date, and we'll just add a specific example. So June 13th. So normally this rule is, every, every Wednesday at 2, but here it's missing this one Wednesday and it's adding a Thursday. Okay, great.
This is how you do like a stock exchange holiday calendar?
Yeah, depending on what the holiday, yeah, like certain bank holidays are like Memorial Day, Mother's Day, those things like those ones are going to be, you can use a rule for it, but yeah, like certain hard-coded days like July 4th, December 25th, things like that. Yeah, you would do hard-coded X dates or R dates or something like that. Okay, all right, so now we're going to do the last exercise in our bus schedule, which is that you can, so far we've been in this idyllic town where buses all run on schedules and things, but maybe it's getting a little like, it's getting a little more real. Like this is like the Wire stuff, right? Because in our hypothetical town, the politicians are like, well, you know what? We really need to do a lot of improvements to this bus line on, let's say, I don't know, like November 3rd, 2020. I'm like, wait, is that election day? And they're like, yeah, how strange, like that you guys can't get to the polls if you take the bus. Oh well. Anyway, I guess it's canceled. So, you know, if you have ethical issues creating like this RRULE set that actually cancels it, like let's just imagine in our scenario that it's not that you're actually making the schedule, but that you're like documenting it and you're going to send it to the FEC and be like, we got to get these guys. So yeah, so let's just be descriptive about it and say, let's use XDate to cancel just 1 day's worth of bus schedule for the day of November 3rd, 2020. And then we'll take, remember to use the green, like you guys may be getting the hang of this, so put the green ones on if you guys are done early, because once a good number of people are done, we'll just jump to the Q&A. So otherwise, we'll finish here at 4:32, something like that, like say 8 minutes from now. All right. So it is 4:32. We have 8 minutes left. So I think I'm just going to show you guys how I'm going to do this. And then we'll kick it into just some Q&A. And then you can always feel free to email me some questions, later if you have them, or if there's a little bit of time after, I'm happy to answer some quick questions. Okay. So show of hands, how many people finished the exercise before this? Okay. And of those people, how many finished this exercise by now? So a smaller fraction. Okay. I'm just trying to gauge like this. I know that I've stacked it, so like the people who are a little slower on the earlier ones, like they are falling further and further behind. But I thought it might be nice to have a kind of theme running through the thing. Great. There's a bit of a trick to this one, I think, in that you can make it much easier. You can just try and figure out what the recurrences are and then hard code them in. Another way to do that is we already have a rule that generates all the bus schedule times during that day, and that's the RRULE that we're about to modify. So if I say recurrences on election day equals bus schedule dot between datetime 2020 11/3 datetime 2020 11/4. Oh, some of you may have tried to like just do an X date on the 2020 11/3, which it would be nice if you could just sort of arbitrarily be like cancel everything on this day, but that's just not how the standard works. And this represents actually November 3rd, 2020 at midnight, right? So if there's not a recurrence at midnight, which there's not, it will cancel nothing. So we have recurrences on election day, right? Which is a list. And so we can just like iterate over this. So like for DT in recurrences. In recurrences on election day, bus schedule dot ex date dt, and then we'll just like cancel those all out. And you can see like if I run this again, it will do nothing. It'll probably make that bus schedule object a little bit bigger, but it doesn't matter, right? So what this did was the bus schedule dot ex date, it generated all the recurrences on that date, and then we just went through one at a time and canceled them. If you want to do R date, you could, there's this bonus exercise where you can use an R date and just manually add in 2 more, and the flavor text is they're like, oh, we're bowing to pressure, so we'll give you a bus at 4:32 in the morning and one at 8 in the evening. But don't worry, you can vote if you just get there at 5 in the morning. All right, so that's done. We have our test passing, and then at the end of the day, we can uncomment this and then actually name it the same as we named it in every other thing. And we get our thing. Oh, it skipped Tuesday. Oh, I thought that it would have a Tuesday in there. I guess I messed that up a little bit. But there should be a Tuesday, and it's empty. But you can see it goes Monday and then Tuesday. All right, so that's our bus schedule. Again, there's a bunch more workbooks in here that you can go through. Also, all this material is public domain. So if you want to take it back to your work and show it to people or whatever, that's totally copacetic from a licensing perspective. So thank you very much for coming to my tutorial, and I would be happy to take some questions. Oh.
On the subject of serializing and persisting datetimes, a couple of questions. How do datetimes play with pickling? Should you ever do that? And then what about like if they're in a database? I know I use Postgres and they have like a timestamp with and without a zone. Do you have any
Okay.
any of that stuff?
So the question is about serializing datetimes. I think datetime works fine with pickle. The time zone stuff, PyTZ and DateUtil will do different things based on using them with pickle. I think DateUtil's zones will like pickle all the information and then give you the exact same TZInfo back, even if your system date time has changed. PyTZ, it may be difficult to deserialize a pickled date time that's aware because I think it may be looking on the system time, or it may give you a slightly different value on different computers. But the packet will be smaller. So depending on what material, like what behavior you want in that edge case, you can pick one or the other, but I would just pick DateUtil anyway. So yeah, but other than that, I mean, generally speaking with pickles, I think you really only want to use that from like one process to another process that are both the exact same Python on the same machine, or maybe on a couple different machines that are all in a cluster. So I think it works well enough for that use case. And then as for databases, I don't know too much about how it works with databases. I think Postgres does an okay job. There was a talk here last year. It was like a 45-minute talk on time zones, and he had a whole section on different databases and how they handle time zones, and it was pretty good. So I think his name was David Goulden or Goulden, something like that. Okay. So other questions?
Just one quick comment. Your last test, it should be 39, not 49. So the test is checking for 39.
What? Which test?
On the bonus exercise,
Oh, it's checking.
I think it's a typo in the instructions.
Oh, so you want this to say 39? Oh, okay. All right, yeah. So thank you. I will fix that. I'll either fix that or the test. All right. Any other questions? Yes.
So something that I could potentially see being, I don't know, maybe sort of fun would be and maybe useful would be the ability to like use plus and minus operators with rule sets. Is that something you thought about, or like would you be open to the idea of like?
Okay, so the question is, could we use plus and minus operators for our rule sets? I think that's fine. I think maybe I would want to override the bar and like binary or and binary and or well, it might be minus either way. But the equivalent operations in sets because it's closer to what's happening. I'll have to think about that. I'm not sure that I really want to be playing with the interface too much because there's plenty of people, like there's a lot of other things to fix. But if you want to jump on the issue tracker and come up with a little, like a little prototype of how it could work, I'd be interested in discussing that. I want the software to be easy to use. Okay, other questions? All right, so it's 4:40. Feel free to leave or feel free to stick around.